Algebra 1, Test 2, Review, which covers lessons 1 through 10. We just did a grade log, so we know which ones we need to do probably the most. Seems like question number 6 showed up the most. All right, it says identify the subsets of real numbers that apply to 15 over 20. So the first thing I want to do is I actually want to reduce 15 over 20. That should be what? 3/4? Okay. So identify the subsets of numbers. Well, is it a whole number? No. Is it an irrational number? No. Is it a rational number? Yes. Is it a real number? And we already know it's not a whole number, right? So the only thing it can be is rational and real because it's a decimal, right? So it's not going to be an integer, right? It's not going to be a whole number. It's not going to be a natural number, okay? And I think this is lesson 1 stuff. So what this should tell me is that I actually do need to go back and look at lesson 1 and see what numbers fall into what categories. Okay? Does that make sense? All right, so that's my recommendation to you there. Okay? Next one on the list was 5. Identify the subsets of real numbers that apply to this. Okay, well, this still needs to be simplified. What is the square root of 64? 8. Okay? What is 8 divided by 8? 1. All right, so it is a real number, right? It is a rational number, right? Okay, is it it's a whole number, right? Well, let's actually, first off, it's what? An integer. It's a whole number. It's a natural number, right? It is everything, correct? So it should be real, rational, integer, whole, and natural. What does the answer key say on number 5? Number 5. Scroll down to number 5. Tell me what it said. It says rational, real, integer, and whole. And so it has all 5 that I've listed up there. Is that right? Okay, good. All right. The biggest deal is that you have to simplify it down. Simplify the number. Because I think what most people will probably say is, oh, look, there's a radical there. Therefore, it's real, but it's irrational. Right? Did anybody say real, irrational? No? Okay, good. All right, maybe you guys are better off than I thought. So, did we just maybe leave something off, or is this just a matter of I didn't do the review and I just want to know what the answer is? No? Okay. Okay. All right, number 8. Number 8, the number of line segments between endpoints is 1/2 times n squared minus n. Use the formula to find the number of segments between 12 points. All I have to do here is plug 12 in for what? In. How many times? Twice. So that's going to be 1/2 12 squared minus 12. All right, well, what's 12 squared? What's 144 minus 12? 12 should be what, 134? So we want 134 really divided by 2. It's the same as, am I wrong here? 32, yep, you're right, 132. Good job. All right, what's 132 divided by 2? Well, is it 66? That sounds right, 66. All right, so that's what I should get. All right, just simply plug it in. Any questions on that? We're flying through this. Great. All right, let's see, that was 8. Next one we need is 11. Okay. 11. If a water tank has a capacity of G gallons and it's drained at a constant rate of D gallons per minute, the polynomial G minus dt can be used to determine the amount of water in the tank T minutes after it began draining. How much water remains in a 4,600 gallon tank that has been draining for 84 gallons per minute for 14 minutes? Okay, so all I have to do is what with these numbers? 4,600 gallons, 84, 14. What do I do with those? Plug them into the equation, right? Where does 4,600 gallons go? Is that G, D, or T? So 4,600. All right. They tell you what D stands for, right? They tell you that D is the constant rate. Well, what is my constant rate? 84. All right. And how long has this been draining? 14. So I got 14 there. So I'm taking 84 times 14. Probably modestly 1,176. Okay, take 4,600 minus 1,176. 3,424 is what I'm told. All right, how much water remains? Okay, water's being measured in gallons. Is that the correct answer to the answer key at the bottom? I'm getting some heads nodding up and down that that is correct. Do we understand this question? It's really not as hard as it looks, is it? No. Okay. All right, so that was 11. 4 questions down, 6 to go. All right, next on the list is all the way down at number 20. Evaluate. All right, so we got to simplify this. This is a big order of operations question. They do throw some symbols in here. They can be a little confusing, but let's take this first part. We got 7 brackets, 11 minus 1 plus 4 parentheses brackets. Let's simplify that. Okay? All right, what do I do first in here? Parentheses inside the brackets, right? So 1 plus 4 is 5, so it's giving me 7 times 11 minus 5. What's 11 minus 5? 6, so we got 7 brackets, 6. All right, let's come over and look at this other part over here. Okay, I'm going to erase this because we're going to hold on to that. We've got 2 parentheses 4 times the absolute value of negative 5. All right, well, what is the absolute value of negative 5? So I've got 2 times 4 times 5. What's 4 times 5? 20. So let's see, we've got plus 2 times 20. Okay, what's 7 times 6? 42. 42 plus what? 40. All right, so I get a final answer of 82. All right, is that the answer at the answer key? Go down and check it. Is somebody confused? Okay. Was that the answer? Okay, good. I just don't want to give you something that's wrong. Okay. 25. Not far from where we are here. 25. A door is 3 feet wide and 6 feet tall. What is the area of the door in square inches? My guess is that you did it right. You just didn't convert to inches squared. We can go ahead and keep this as feet and then convert to inches at the end, or we can start at inches at the beginning, and then we're good. All right. I prefer to start with my correct units at the beginning, and then I don't have to worry about it. 3 feet is how many inches? 36 inches. And 6 feet. What's 6 times 12? 72 inches. So we have 36 inches by 72 inches. What's 36 times 72? 2592 inches squared is what I'm told. Is that correct? Okay, is that the answer at the bottom? Okay. All right, so how many of you just took 3 times 6 and got 18? Probably not very many of you, because not very many of you actually did the review. All right, but you need to pay attention. All right, I've talked about this with the geometry class. They also have a test tomorrow. The 3 biggest things that cause problems on tests for students are what I call unforced errors. Do you know what an unforced error is? No? An unforced error is where a player on the field makes a mistake without anybody else around. Right, like they throw it to the wrong person, or, you know, like a receiver catches the ball and then trips over his own feet and fumbles it. right? Unforced error, nobody was around him, nobody touched him, he made the mistake all by himself. We have unforced errors in math, and that's when we do one of what I typically call three things. We don't read the question, right? We just assume we know what the question is going to ask us to do, right? We don't answer the question that's being asked. That is usually associated with the first thing, right? Or we don't write the question down correctly, or we lose something, right? We have bad handwriting, and so we can't read our own stuff, and we end up making mistakes just because of not following our own work, right? Those are what I call unforced errors. Those are the things that we get really frustrated by whenever we look at our tests and we grade our tests, and we're like, I knew what I was doing, I just made a bunch of little mistakes. If we can do away with the unforced errors on our tests, usually I think that you're probably, unless you get a perfect score, I think that you can probably eliminate at least 3 wrong answers off of every test if we just get rid of the little mistakes. Okay? And this is going to be one of those things where you're going to miss this, not because you don't know how to do it, but because you're going to, 1, not read it, or 2, assume. Okay, 3 times 6, 18. That's going to show up as part of one of the answers. Okay? So be careful with that. And I know that even though I've said that, on Wednesday when we are doing our test corrections, I'm still going to have people who are like, oh man, he said that on Monday, right? All right, let's look at number 7. Number 7, the temperature on the ground during a plane's takeoff is 21 degrees Fahrenheit. At 38,000 feet in the air, the temperature outside the plane is negative 28 degrees Fahrenheit. Find the difference between these two temperatures. All right, how far apart are they from each other? All right, so you're basically looking at 21 minus negative 28, right? That you're going to find that the difference between those. Okay, so it's an absolute value. You're looking at a distance. So 21 plus 28 should be there's 49 degrees difference. Was that the answer? Okay. All right, so we know what to do with that then. It's just like on a number line. Okay, if you can imagine a number line, that's what you're looking at. Okay, after that was number 10. Okay, identify the irrational number. I think you saw this maybe on your last test, didn't you? Okay, so it should be a pretty familiar question. Irrational means, 1, it's got to be a decimal. 2, it has to be a decimal that doesn't repeat. And 3, it has to be a decimal that doesn't end. All right? And this B here is kind of confusing. I don't know if that was supposed to be a 13 or what, but neither 1 nor 3 are irrational. 0.43 is a decimal that ends. The square root of 144 is 12, so this is just coming off as negative 12, which is not irrational. 1, it's not a decimal. So I would plug in square root of 91 in my calculator and see, is it a decimal that has a pattern to it? Does it seem to end? It probably doesn't. So square root of 91, check it out, should be my irrational number. Yeah. Yep, so square root of 91. And the other hint for me, but I'm more familiar with it than maybe you are, is that 91 is a prime number. The square root of a prime is typically, in fact, every case that I've run into, is a irrational number. Okay, the square root of a prime number is typically an irrational number. All right, 13. 13. The distances ran in a race are shown in this table. List the distances in order from greatest to least. Between which 2 students' distances should Maria's distance be in the list? So you have to be able to convert these to the same form. Okay, you can either convert it all to eighths, or something else, or get them all as decimals. Probably decimals is going to be a little easier. What is 7/8 as a decimal? Anybody? 875. And 1/20th, that'd be the same as what, 2/10. So that should be what, 0.2. All right, so we want these from greatest to least. Okay, so looks like Stephen, it would be first, right, with 0.875. After that is what, Maria, with 0.75. Okay, After that, it looks like Patrick with 0.35. Then you have Lou, right, with 0.3. And then finally, we have Jacqueline. Okay. List the distances. I didn't list the distances, but the distances are there. You guys can see that. You can put their names under there. Between which two students' distances should Maria's distance be in the list? She should be between Stephen and Patrick. Is that the answer in the answer key list? (1/20th)? Oh, okay. Did I mess that up? Give that to me again. 0.05. Okay. That still didn't mess us up though, right? She's still at the end. Okay. Was Maria between Stephen and Patrick? Any answer key?
Yeah, well, it's the decimals.
Oh, they give you the decimals. Okay. All right. Do we understand this question though? Okay. All right. Let's see. That was 13. Last question that really seems like we need to cover is probably 17. Identify the set of numbers that best describes the following situation: number of students on the playground. Well, we're not going to get half of a student. We're not going to get a fraction of a student, right? Okay. So everything that we should run into should be rational, should be an integer, should be whole. The only thing that we shouldn't get is an irrational number. Okay? Is that the answer? Okay. Answers. Is it just A? Oh, I understand. Because when we're talking about students, we can't get a negative student, right? And a rational number can include decimals, right? So the only thing that really fits is just the whole numbers. Okay? Okay, that was all of the up to 2 people. At this point, are there any questions that you guys have that weren't covered? Okay, because we didn't go through, I don't think we went through all the 2s, and we didn't go through any of the 1s. You guys are good? Okay. All right. Well, I'll hit stop on this then and try to get it out to you.